We have what, 6, 7 folks on Zoom and similar number of people on YouTube as well right now.
Sorry, what's that, Anshu? I didn't catch that.
We have 6, 7 folks on Zoom and similar number of people on YouTube as well right now. Yeah, just was talking about the number of people on Zoom and on YouTube. Uh,
Sorry, what's that, Anshu? I didn't catch that.
we have
Yes.
6, 7 folks on Zoom and similar number of people on YouTube as well right now. Uh,
Sorry, what's that, Anshu? I didn't catch that.
Hey folks, morning. More folks joining in. Let's give another 5, 10 minutes for more to join and then we can get started.
Good morning.
Hey Tripti, morning. Devanshu will be joining us in a while. He has got some power issues at home, or rather, yeah, in the apartment. Yes.
So, Anshu, typically you guys do a bit of introduction to the event and then start off the talk, or it's just the talk right away?
Yep, sure. So, hey folks, welcome again to LSP 35th event since we started and fourth event of the year. Has been an interesting year. Thankfully, we are at least coming to the calendar end of the year. Let's see how long the interesting factors keep on going. But yeah, and when can we get back to our usual meetup format? Uh, I see a whole lot of known names. So yeah, I think fourth event of the year, it will just continue. Be an interesting year. We are at least coming to the calendar end of the year. Let's see how it. Hey, so there's a bit of echo from someone.
That was me. I fixed it.
Yeah,
Sorry.
okay, yeah, no worries. Yeah, so yeah, just as a brief update on, let's say what we have been doing, right? The event, the community has been holding strong despite the year, and we have had decent number of participation throughout all of our virtual events as well. Today also we have more of such interesting talks coming up. Before we talk about the presenters and the events, I think we will wait for a little while for some more folks to join here and on YouTube stream. Till then, I think we can quickly get started with introductions from everyone who's out here, and then later on we'll get intros to the talks and the meet. So yeah, let's uh, start off with the folks whom we have here. I'll say Abhishek. Do you wanna start with yourself, Abhishek Patra?
Hey, hi. Can you hear me?
Yes.
Okay, great. Hi. Uh, Hi. So, I actually work at Verizon Media right now, and I just graduated from college last year in July. I've been here for like nearly 1.5 years now. So I'm working in the front page team, which we are responsible for the uptime of all the various user facing the websites, right? The www.yahoo.com and in the different countries, and news, entertainment, lifestyle, all those websites. Uh, and we have that's our core duty, making sure that they're running effectively. Yeah, so still pretty new here, and uh, taking a lot from these kinds of meetups and conferences as they come. So yeah,
Nice. Welcome.
thank you.
Thanks, Abhishek. Yeah, so I'm just gonna go in the list, in the order of the list which I can see on my Zoom screen. Hopefully, everyone has pretty similar list. So, Anup Deshpande, if you wanna go next.
Yeah, hi Anshu. Good morning. So I'm Anup. I work for Walmart Labs as a backend engineer. So my I work mostly upon API development and batch processing. I'm part of marketplace team. Yeah. Thanks for organizing the meetup.
Thanks, Anup. Thanks for joining us.
Thank
Uh,
you.
Dilip Chaudhary.
Hey, hi, good morning to everyone. My name is Dilip Chaudhary. Right now, I am an intern at Philips in the automation testing team. So I'm looking for a job right now for a backend profile or a SD profile. Thank you.
Thanks, Dilip, and welcome to the meetup. Hopefully, yeah, some of the pieces that we talk about here would be of help to you, and hopefully we hope to learn from you as well in the future. So yes, welcome again. Girish Bhatt, and
Yeah, hi, Girish here. I am from Walmart Labs. So basically, I work on big data stuffs like in GDAP what we have. So currently working with multiple hybrid clouds, those kind of tech stacks. So this is my first meetup. I am familiar with the Bamshu and other people, but I wanted to learn, how to handle multi clouds and what technologies people are building outside. Yeah, I'm kind of excited to meet all you all. Thanks.
thanks, Girish. Welcome to your first meetup, and yeah, hope
Yeah,
to have you again in future as well.
yeah,
uh,
sure. I would like to.
Thanks. We have another Girish Chandramohan.
Hello. Hi, I am Girish Chandramohan. This is my first meetup as well. I am in Akamai Technologies as an architect, and I'm interested in big data technologies, how to run them in the cloud environment, in a hybrid environment, actually. And looking forward to understanding from the experience that you guys have to share. And the scale of the problems do interest me a lot. So this is where I plan to learn from you guys, and hope to continue with meeting you regularly.
Thanks, Girish. Thanks for joining us. A whole bunch of new folks and faces today. So yeah, welcome. Irfan Muhammad.
Hey, my name is Irfan, and I'm a software dev engineer at Verizon Media. I've been on to Devops for a while now. I joined Yahoo in 2017, and yeah, I work with identity platforms, contributing a bit to the backend system as well as the front end. Yeah, thank you for organizing this meetup. It's
Thank,
great to be
thanks, Irfan. Yeah, Pawan Pandey.
Hey, hi. Myself, Pawan. So I work at system infrastructure team at LinkedIn, and I'm part of the team that is responsible for managing config infrastructure and repo infrastructure at LinkedIn. Looking forward to this meetup, and thanks for organizing it.
Thanks, Pawan. Raghav Bijula.
Hey, hi everyone. I'm Raghav Bichla, working for Thomson Reuters based of Hyderabad. So I got introduced to LSP by one of my colleagues a couple of years ago, and I used to come all the way from Hyderabad to Bangalore to attend these meetups. So and it's really great opportunity for me today to be a speaker for one of the topics. Thank you.
Thanks, Raghav. So yeah, I think looking at that sentiment, this has been an interesting year. We have been trying in the past as well as to how we could, get the event online and how can we get it recorded. So in the earlier days of the event, back at Yahoo, we used to have a whole lot of recordings. We never really managed to get them all online. We have a few pieces here and there, but I think this year kind of forced us to get it online, and hopefully even when we get back to in-person meetup, now that we have almost sorted it out, we should be able to continue doing this in a similar manner, and yeah, hopefully we'll have more participation from uh, across the country and globe. A fun fact, we have already made benefit from this format, right? I think in the last event, we had participation from Zurich. One of our community members was able to present it from there, which otherwise would not even have been possible, right? So yeah, definitely. So yeah, welcome, and I'm looking forward to hear more from you.
Thank you.
Thanks, Raghav. So Rohit D.
Hey guys, so I'm Rohit. I work at Hotstar. This is my first meetup with the LPSC. I was at Yahoo from 2007 to 14. I've always seen LPSC from outside, and I used to learn about the meetup post the meetup happened. And this time I figured out I should join before the meetup. So I joined the group this week. I have seen past recordings, but there's definitely the scale part which attracts me from my previous jobs and my current job, and I'm hoping to learn more from everybody's experience.
Thanks, Rohit. Thanks for joining, and welcome back. Sorry, someone was saying something? Okay. Roland, welcome. So yeah, would you like to quickly introduce yourself again?
Sure. My name is Roland. Anshu said. I work at Flipkart as part of the internal cloud platform team. Within that, I am largely focused on our central monitoring and observability platforms. That's logging, metrics, traces, and so on and so forth. Yeah, a couple of us spoke about our logging infrastructure a couple of sessions back. If I remember correctly, it was the first virtual meetup a couple of months back, sometime in May. Yeah, so why am I here? I like things tech in general, and especially tech at scale. So that's what I hope to learn more and more from the folks on this forum.
Thanks, Roland. And yeah, definitely, I think it was one of the first early events. For folks who are looking for that particular event that Roland was talking about, it is on YouTube, but because it was earlier days, we didn't have it sorted. So unfortunately, it's on my personal channel. It is public, but yeah, it's not on the LSP channel. It's on my Anshu Pratik channel. So yeah, I will see how for us to move it, it's literally a download and then re-upload. So yeah, not an easy task, but yeah, we'll see how we can get it onto it on the LSP channel. Sanjay, welcome again. So yeah, please introduce us. Please introduce yourself to us.
Hey Anshu, nice to see you again, and nice to see the members of the the forum. So my name is Sanjay, and I am currently working with Walmart Labs. Previously, I was working with Yahoo and Twitter. So I've been, very much regularly participating in this event and been learning a lot from the community and the nice topics that on the different technology stack, which the members of this forum is been talking. So it's really a very great opportunity for me to really interact with so many people and then learning from them. So that was the one reason why I'm joining this meetup regularly. And yeah, I mean, I really can't wait to be within 6 feet of you. But then I think for now we all have to be virtual, and yeah, looking forward to attend more and more sessions in future. Thank you.
Thanks, Sanjay. So yeah, definitely looking forward to see when we can meet everyone again in person. But yes, till then we'll have to manage with this. Shanuga, you wanna go next?
Yeah, hey guys. So I'm Shamga. I've been with Verizon Media, Yahoo Verizon Media for about 12 plus years, and I've been actively like participating for a couple of last couple of quarters, and it's really nice to see like what is new in the technology and what people are kind of what is it doing in their organization to make things better at a large scale. So. Yeah, I keep coming to see and then learn and adapt and share things. So yeah, it's all about.
Thanks, Shanuga. Soumyadeep Mahapatra.
Hey, I'm Shamideep. I work at LinkedIn in production infrastructure engineering team. Today, me and Pawan both will be talking about unified configuration management at LinkedIn. So, really grateful for the opportunity to to be able to present to all of you guys. Thank you so much.
Thanks, Soumyadeep. Tanmay.
Thanks, Anshu. Hi, team. So I work as a DevOps engineer in Jungly Games. So I am managing two orchestration platform now, Kubernetes and Nomad. So we are now starting to enforce, or we are starting to introduce that DevSecOps culture in our team. And so the last talk of this meeting will be helpful for me for that. And we have one or generic CI/CD pipeline. So one unified pipeline that will. Or we are.
Thanks, Tanmay.
Basically, the unified configuration management I'm looking forward to. So whether I can integrate the unified CI/CD pipeline with the configuration management.
Thanks, Tanmay. Tripti.
Hey everyone, good morning. It's a very bright Saturday, so it always feels good. And thank you for attending this session. I really enjoy. I've been associated with this group for a long time, and know Anshu, Devanshu, and everyone here almost being part of the ex-Yahoo group. But I really love this group. There is a lot to learn. And to introduce myself, my name is Tripathi. I'm EM. I manage two teams at Twitter, the data platform team, which is Hadoop, big data, and the other one is database around MySQL, Postgres, Vertica, and Druid. And for me, why I join, I get to learn a lot. And also me and my team have presented in various talks. So looking forward to awesome talks today. Good luck and good to see you all.
Thanks, Tripati. Welcome back again. And Vijay.
Hi, I'm from Verizon Media. This is my first event, and I'm looking forward to it. Very excited.
Thanks, Vijay. Hey, a whole bunch of folks would have joined in between while we were doing the intros. Unfortunately, I do not have an easy way to track. I didn't do a pre and a post screenshot for me to compare. I see a couple of folks, yeah, some names I can definitely recognize, so whom I would unfortunately, kind of bug them and bother them and call them out. So, Jessica, do you want to go and introduce yourself? Jessica, are you there? Okay, so okay, not sure if she's around. Anyone else who has joined in between? Ashutosh, I saw you joining, so yeah, welcome and would you like to introduce yourself?
Hey, morning everyone. How are you? So my name is Ashutosh and I work for Myntra right now. I'm taking care of a couple of teams.
The side.
Am I audible?
Yep, can hear you.
All right, sure. So I work for Myntra. Previously, I have been associated with Samsung R&D and Yahoo. So been a long time associated with LSP. Good to be around here. So find time as and when we get it to attend these events. In short time, we learn a lot. It's a good part of it.
Thanks, Ashutosh. Couple of other names that popped up. Deepak Soni.
Yeah, hi, Anshu. So this is actually I've been associated with this group from Walmart. I think previously we had an event there, right? And right now I'm associated with the HPE storage division, right? And looking forward to learn a lot from this group.
Thanks, Deepak. Welcome back
Thank you.
again. Dilip Chaudhary.
Hey Ansu, I'm already done.
Oh, okay. Sorry, my bad. Dinil Anthony.
Hey guys, I'm Dinil. I work in Samsung Research. I'm here to network with you guys and how various industries do the DevOps, DevSecOps, DBA ops, all these activities. How you guys do that. Looking forward. I think this is my third or fourth LSP event, and I work under the Banshu. So most of you know the Banshu here. He's one of the organizers for this event. Yeah, thank you.
Thanks, Dinil. Welcome. For folks on the YouTube stream, feel free to jump in on the Zoom stream if you want. Uh, Anyone else out here who joined while we were doing intros and would like to talk about themselves? I see at least one more, Girish Sivakumar. Girish Sivakumar, what do you want to go next?
Hey, hi, Hanshu. Uh, I've been looking forward always for joining the LSP meetups. So it's a very good place to learn. And I was started joining this when I was in Walmart. Now I moved on, but I always look forward to joining here because generally I'm interested in working with staying up to date with how people do stuff with scale and perform at scale. And this is one of the best places to get to know who's tried out what and how it's worked for them. And not always you get an opportunity to work at this level, but when you do get, you need to know what are the options are. I think that's one of the best places. So always look forward to come back here and see what's happening in the industry and learn from the community. That's
Thanks,
great.
thanks, Girish. Thanks. Yeah, definitely. I think that's one learning point which we all look forward to. So yeah. Uh, Anyone else? I'm sure I've missed a couple of folks who joined while we were doing, but anyone else want to go next?
Everyone, this is Abhishek. So I currently work at Twitter on the data platform team as an SRE. I worked previously at Yahoo, then Walmart Labs, and I come here so that I can get some great info into good architectures and really a lot of good insightful talks. And last but not the least, definitely to again meet and greet people whom we know, like a lot of familiar faces around. Like hello to everyone.
Thanks, Abhishek. Welcome back. Uh, let's jump onto our host, Venu. You had stepped away briefly when we started, so yeah, over to you.
Oh, sorry. No, I'm fine. Thanks, Anshu and everybody else for setting this up. I work at LinkedIn. I'm on the data SRE team. I manage LinkedIn's Kafka infrastructure and search infrastructure. This LinkedIn has been associated with LSP for like years now, but and it's been obviously great to have people from LinkedIn talk and also like have hear all of your awesome speakers come in and talk about the cool topics that keep showing up every quarter. I personally, this is my first LSP event, and I'm again very excited. I'm looking forward to the talks. As Anshu mentioned, I'm one of the organizers today, so if there's anything that I can help with, please reach out to me. Thank you.
Yep. Thanks, Venu. So we have about 29 folks out here, and about 33 33 hosts. Might be looking at wrong numbers, but yeah, similar number of people on YouTube. I think we are good to get started. I think there are 7 folks on YouTube. So yeah, lower number on YouTube today, but yeah, let's get started. So Venu, would you like to introduce the first set of speakers and the topic, and yeah, we can get started. You are on mute, Venu.
Oh, I'm sorry. All right. So yeah, the first set of speakers today are Soumyadeep Mahapatra and Pawan Pandey from LinkedIn. They're going to be they're on the production infrastructure engineering team here at LinkedIn, and they're going to be talking about how they've re-architected parts of our unified configuration management platform. So without further ado, I guess take it away, guys. Soumyadeep, can you hear us?
Yes. Let me share my screen. Just a second, guys. There's some problem with sharing.
Yeah. Demo day gods, they always come into scene. So yes, take your time, no worries.
If I'm not able to share my Firefox screen, I'd request Pawan to.
Yeah. Just give me a minute. I'll just share mine.
Yeah.
Yeah. 1 minute. Just press it.
Hey guys, so basically I'm Soumyadeep, and along with me we have Pawan. Both of us we work in the production infrastructure engineering team. Today we'll be talking about unified configuration management system at LinkedIn, how we use configuration management system at LinkedIn, what changes we have made internally. We'll be talking about all of those details, the use cases, etc. So let's go to the next slide. Okay, the role of configuration management system, I believe that this is no different than any other organization. So we use configuration management system to do a bunch of changes related to operating system configs. For an example, customized sysctls for applications, limits. Basically you limits SSD configuration, security hardening, RPM installation, etc. Along with that, the configuration management system is also responsible to control certain aspect of application configurations. For an example, pre-deployment tasks and configs. The data systems might require, data disk configuration where they would dump the application data. For an example, SSD configuration, or let's say, software RAID configuration, or JBOD configuration, etc., etc. Also, there might be things like dependency installation, as well as runtime environment installation. So all of our machines should be configured with, let's say, the JDK and the Python, all of those things that would be required for an application to be deployed and basically to run. We also use configuration management system to, deploy various agents that would be responsible for collecting statistics, monitoring agents, for an example, health agents, application health agents, etc. As well as there are a bunch of CLIs that would be required for, troubleshooting application or monitoring various aspects of application, etc. Those are also deployed using configuration management system. Pawan especially is going to be focusing on the agent CLI deployment part of it, and he will go in much more detail than me on this one. Let's go to the next one. All right, so
a quick question at this point.
Sure.
Can I ask one?
Sure.
Are these static configurations only, or do you also handle dynamic configurations? For example, if somebody wants to change a logging level on the fly, do you cover that too?
Most of the configurations are static configurations. So for an example, like login, okay, so you mean the log level of some...
Yeah, that was just an example. It could be any dynamic configuration that you want to change at runtime without having to probably do a redeployment if you handle it that way. But yeah.
Yeah, so most of the things that we do are static configurations, which means that would probably require a restart of the process. Basically, let's say that if there's an so we don't control the logging level of an application using config management. That would be specific application configuration, and there you have an option to go dynamic and static. But the config management system that we use to control other aspects of application configs and the system configs are pretty much static. Would require, yeah.
Understood. Thank you.
Cool. So we already had a config management system. Obviously, we were not operating without a config management system since inception. Why we needed to revamp config management system? We had CF engine as a config management system, and there were a few limitations. The way CF engine was set up, the way we used to operate CF engine. We could not give self-service ability to the SRE team, various SRE teams to control their, let's say, sysctl limits for their applications. In a way, the limitations basically comes from the way we used to manage CF engine and host CF engine and allow who could control what. It was not flexible, and we could not separate the logic from the data. CF engine has a very tight coupling. The language specification actually ties data and the logic very tightly. There was no way for us to separate the two. So that, for an example, the SRE teams that would like to change a few sysctls, they don't have to get into the details of how sysctl configuration is managed, right? So there was also challenges on proper targeting of changes. The way CF engine works is that all of the policies would go everywhere, regardless of... Yes.
Guys, could you go mute if you're not asking a question or talking?
All right. So basically, the targeting of changes was challenging. We would introduce, let's say, some bug, and that would land up everywhere, regardless of where we wanted that piece of code to be executing. And it would happen very frequently. And basically, what we wanted was that we would be able to target our policies to specific set of machines. The data and the code would be landing up onto that set of machines, nowhere else. Also, we wanted customizability, as we wanted to integrate with the broader ecosystem of LinkedIn. We wanted the flexibility, the customizability, and being able to control how we can scale configuration management system. Stronger community was another driver for this revamp. With CF engine, the people, the number of people that were familiar with Safe Engine or would be interested to learn Safe Engine became lesser and lesser over the years. We discovered a lot of major bugs that we wanted to work with the Safe Engine community, but the timelines, the priorities did not match up with our upgrade schedules. So we were looking for a configuration management system that would actually fit into our ecosystem, and as well as have a large user base that we can leverage, the expertise we can leverage. Probably we can go to the next slide now. So what is unified configuration management system? One thing that we did not want to do was obviously to reinvent the wheel. So we did not want to rewrite a configuration management system from scratch. That means that building something like Puppet Chef from scratch. Instead, we wanted to take the core of configuration management system, and we wanted to kind of customize that in such a way that we not only fit into our existing ecosystem infrastructure, as well as we provide all of the things that we wanted to provide through configuration management system. So after a lot of testing and talking to the various communities of configuration management system, we decided to go with Puppet. The reason for that would be majorly because Puppet already had a large amount of user base. People were familiar with Puppet. The DSL is really easy to grasp. The learning curve is very low. Regardless of whether you know Ruby or not, you would be able to pick up Puppet within a couple of days. Also, one major thing that attracted us to Puppet was that the ability to separate data from code. So Puppet uses hierarchy data to separate out the key value pairs from the logic. That was very important for us to separate out two different pipelines. What we observed was that the logic change happens very rarely. For an example, there are probably one or two ways to control sysctls or installing RPMs, or like, let's say, restarting a service after you have changed a configuration, etc. But the configuration parameters would vary from application to application, from service to service, and that would change much more frequently than the logic that controls the configuration. So separation from logic, separation of data from logic was very crucial for us. We also wanted to ensure that we give the platform as a self-service platform. We enable the SREs to control the system parameters that would be customizable per their application. Previously, what used to happen was that they would be dependent on the specific team that would do the configuration changes for them, and there would be obviously turnaround time associated with that. We wanted to give much more visibility into what goes onto the system than we could do with CF Engine. Also, we made it highly scalable. We kind of stripped away Puppet, like the typical Puppet infrastructure. We don't use Puppet master agent setup. During the testing and evaluation, we did not get enough confidence that Puppet master agent setup would be able to scale to our needs. We instead, what we do is we just use Puppet apply on every single machine. One of the things that Safe Engine was doing right and did well for us was that the policies would land into every single machine, and every single machine, independent of each other, would determine, depending on their facts, what needs to be running on those same machines. Which means that you are not actually pushing your infrastructure, configuration management infrastructure for scaling. Basically, each and every node would be doing the processing, catalog compilation, etc. All those heavy lifting for you. There's no central server that takes decision for them. Also, we wanted to leverage in-house tools. There's a rock-solid infrastructure, developer productivity infrastructure that exists in LinkedIn. So we wanted to kind of take advantage of all the existing CI/CD pipeline, Git repositories, all of those productivity experience, so that regardless of whether you are dealing with a Puppet module or you are developing a Java app or you are developing, let's say, Python or Golang app, you would get the same set of, get to deal with the same set of tools, and your expectations and the experience would be obviously the same. Also, along with that, we have the existing infrastructure services like service discovery and monitoring services. We wanted to leverage and plug into all of those services for our needs. Let's go to the next slide. So this is on a very high level how our UCM infrastructure looks like. We have separated the Puppet modules and Hira data. Let's say that I want to develop a custom module. I'll be creating a project of Puppet modules, and I'll write my codes. I'll get it reviewed, get shipped it from my peers. Once I do that, I'll be pushing those changes, and the Git post commit hooks will be taking over from then onwards. We use Gradle as our basically build tool. So basically what will happen is that there will be a Gradle task to create artifact Puppet module. So it will go through all of the validation. If there's unit test, it will run on all of those. If everything passes, at the end Gradle will create an artifact, which is a tarball. And the tarball will be pushed to Artifactory. Once again, Artifactory is used as a repository for us. So the artifacts will land up in Artifactory store. Similarly, for Hira data as well, we use our Git repositories separate from the Puppet module Git repositories. And basically why we wanted to do that, because we wanted to separate data from code, and the frequency of changes in the Hira data repositories would be much more than the module changes. So there are two separate repositories. And once the artifacts are published in Artifactory, they are actually synced using UCM Artifactory Sync. It's a service that monitors whether there's any Puppet module, new version of Puppet module available. It downloads that module from Artifactory store onto UCM file server. UCM file server is another service that, depending upon the the roles and the external facts of a node, it's gonna reply with what set of modules and their versions that node would be running. Similarly, for Hira data, we have UCM Hira ingester that does a lot of validation, from basic YAML validation to whether somebody has should be able to push certain Hira data for a specific module or not, and for which module they would be able to push Hira data or not. All those validations are done by UCM Hira ingester. Once those validation steps pass, we ingest the data onto Couchbase. We use Couchbase as a service. It's an internal service. And we have a proxy in front of the Couchbase cluster. The functionality of the proxy, or the significance of the proxy, was to limit the number of connection that goes into Couchbase. Even though Couchbase is, will be happily serving few 100,000 requests per second, we wanted to limit the number of connections that are hitting the Couchbase clusters, because we'd be one of the tenants of the Couchbase cluster. So we did not want to hamper other services. The Couchbase proxy is once again, it acts as kind of like source of truth for the Hira data. And we use Hira data to further control what goes where, which module goes where, which is once again consumed by UCM file server to determine what set of modules would be executed for a specific node. Any questions so far? All right, then we can go to the next slide. All right, so this is a continuation of the infrastructure. So basically we talked about the infrastructure services, Artifactory, Sync, UCM file server. What goes on a specific node is a set of these tools like UCMFS client that would talk to UCM file server to download the module artifacts. UCM ENC talks to our LinkedIn service registry to figure out what application would be running on a specific node, and it dumps those as external facts for Puppet. UCM Hira Retrieve talks to UCM Couchbase proxy to download Hira data specific, module specific Hira data for that node. And once all of those things have successfully completed, we execute Puppet apply. And once Puppet apply has finished running, we process the Puppet execution report. That's UCM report client. So basically what we are interested in is that, for an example, if I'm writing a custom module, I want to ramp that custom module to certain set of machines, and definitely we'd like to have some sort of indicator whether that module is working properly or not, whether it's failing somewhere and why it's failing, etc. Or let's say we want to be able to see the versions of those modules, right? So UCM report client processes the Puppet report, and it basically makes a call to UCM report exporter, which further uses Kafka and Azure Data Explorer to basically create a Grafana dashboard. We also use InGraphs. InGraphs is our internal tool for monitoring. It's a dashboard and alerting tool for monitoring. If you guys want to know more about InGraphs, there's a engineering blog about it. So basically we use InGraphs to monitor each and every node's health, whether Puppet is executing properly or not on a very high level. And that much more detailed report comes from Grafana dashboards. So that's pretty much about it about UCM infrastructure. Do you guys have any other question? All right. So if we don't have any question, we can go to the next slide. And with that, we'll give control to Pawan.
Okay, thanks, Soumyadeep. Hey guys, so I'll be taking up one of the use case of unified configuration management. I mean, definitely there are a lot in LinkedIn, but in this presentation, I'll be talking only about one of them, which is Cli Distribution Platform. So what is the need for like command line tooling distribution platform? So even though you have this build and deployment pipelines, but there are a few things that needs to be deployed outside this build and deployment pipelines. So like the deployment agent, I mean, you need the deployment agent to be available on all hosts across the LinkedIn infrastructure for deploying the applications. You need monitoring tools to be rolled out for monitoring the health of the applications. And like that, like there are different other use cases for other agents to be rolled out. One of pushing the RRDs to InGraph. So we need some kind of agents to be deployed on all hosts for pushing the RRDs. So like this, there are different use cases for CLI distribution platform. In the cloud environment, like it's very easy because I mean, you do the release based on ISO. Like you build a, if you're doing a new release, you just build a new ISO and just install, like create a VM out of it. But in LinkedIn, like we have a lot of hosts running on bare metal. So and there are a lot of hosts which are stateful. So it's not easy to roll out a new ISO and like reimage boxes. So we need some kind of like platform to rolling out this command line toolings. You can always bake this tooling in ISO, but again, it's the same thing, like because we don't want to reimage host. So you need some way to upgrade all these CLI tools. We had like configuration management earlier, but it was not open to the SRE. So it was not easy to like roll out those CLIs using the like config management that we had, which is CF engine, and what Somidi point. So let me explain how we used to do this CLI distribution before UCM. So like few years back, we had hardly like, I mean, a handful of CLIs to be rolled out across the infrastructure. And it was amounting to maybe like few MBs only. So what we used to do, like we used to like leverage our build pipeline, and we used to package all these CLIs into a single tarball. Once this tarball was built, we used to leverage our config management CF engine and torrent technologies for distributing these tarballs across all the hosts in the infrastructure. So config management was required because torrent will only work once the torrent file has been like deployed across the different hosts. Like, I mean, if a given host has to participate in the torrent technology, it has to know the torrent meta file. So we used to use CF engine for distributing the torrent files, and then using the torrent technology, we used to like download or distribute the tarball across the entire fleet. So when we started this system, it used to fit very well with the use case, because the tarball size was like in MBs, and I mean, and it used to like distribute it across all entire fleet like in a short duration. But over the period of time, with more CLIs coming into the picture, so basically in LinkedIn, I mean, there are different teams and different custom applications, and they need some set of CLIs to be deployed to their set of hosts for managing their applications. So over the period of time, this all CLIs, the size has grown up to in GBs. And with this legacy system, it was a huge IO network cost. So you can think of like if there are 1 lakh boxes and you have to distribute a 6 GB of like tarball across entire fleet, it would be somewhere around 600 terabyte of network bandwidth at the minimum. That's not the only one, because we had to do like in place update, atomic update. So even a single bit of change in any of the CLIs, there was a new tarball that was used to be rolled out across entire fleet. So, and once this tarball used to be available on the host, there was a IO extraction that used to happen. And because of that, there was a huge IO cost as well. We have seen like whenever this extraction used to happen, there was like some application used to notice some performance degradation. So this is how our legacy system for CLI distribution used to work. Now let me share how we are doing it using the UCM based system. So with this UCM based system, what we are doing right now, so for every CLI, there is there is a repo, there is a Git repo available for the user. What user does, it does the Git commit to the repo. After like peer review, definitely. Once the commit is done, there is a build pipeline available which triggers the build of the CLI. And this CLI, once the build pipeline is triggered, the CLI is packaged into an RPM, and then it is uploaded to the RPM repo infrastructure, the HTTP repo I'm talking about here. So once the RPM is available in the repo infrastructure, it's like CLI owner can decide when to install and how many hosts he has to install this given CLIs. So what he has to do, because the UCM is self-service to SRE, what they have to do, they have to just push the higher data for respective to the CLI installation, and the UCM, once the UCM is triggered, the installation will be kicked in on all the boxes. So what are the gains we had with this new UCM-based platform, considering the legacy infrastructure we had? So one thing was, for now, if a given CLI has to be changed, only that CLI has to be rolled out on the target set of hosts. So considering the previous, the legacy system we had, which was the tarball size was 6 GB. Now only if you consider the average size of a CLI, it will be like 50 MB. So only the 50 MB RPM has to be shipped across the target set of machines. If you consider the 1 lakh boxes, definitely we have much more than that. But if you consider 1 lakh boxes, with the previous legacy system, we had around 600 terabyte of network bandwidth usage. And with this new UCM-based system, since we are only rolling out one particular CLI, if you distribute this 50 MB of CLI across the entire set of machines, it would be 5 terabyte across the entire data center. So there was 25 times reduction in the network cost. The deployment time also has reduced a lot. Like in the previous legacy infrastructure, what we have to do, we had to download the tarball, then we had to generate the torrent file, then we had a set of seeders to which this torrent file and the tarball has to be rolled out. And from there, it used to go across the entire fleet. So somewhere it used to take from 1 to 2 hours, the deployment time. With this new infrastructure, the UCM-based platform, now you can think of the moment you do the git commit, the build pipeline is triggered, RPM is created, and it's uploaded to the repo. Now it's up to the CLI owner. The moment he pushes the higher data respective to that RPM installation, the installation will be kicked in, and you can think of if the max, it will take 10 to 15 minutes in the deployment time. Now, how UCM help? So one of the thing was with our legacy infrastructure, we had to roll out this tarball across all the machines. There was not a selective installation available to us. But with UCM, because it's a self-service, now the CLI owner can think of how many machines he has to target his CLI. So with UCM, there was now a support for subscription-based model. The monitoring has improved because the UCM provides you to the monitoring data to see the states of different modules available on different hosts. So now we can easily monitor the CLI footprint. So if I rolled out a CLI, you can definitely check how many hosts the CLI has been installed. The third, last but not the least, now we have a selective downgrade which is feasible. So earlier it was only fast forward, but with UCM in picture and with the RPM package management of Puppet, you can definitely downgrade your CLIs. You don't have to do a fast forward rollout. That's all from our side. We are open for questions.
Thanks, Pawan. And thanks, Soumya. So yeah, any questions, folks? Okay. Yeah, so I think one question that I would have from my side is, let's say, if others have to do such a setup or replicate such a setup, right? How how much of a challenge do you foresee this would be if someone has to implement it on their own? How much bandwidth, how many people does it need to get such kind of a setup up and running from configuration management perspective, and what are the operational overheads for the system?
So I can probably take that question. when we started unified config management system, at least brainstorming the ideas, capturing all the issues that we had with CF Engine, we started somewhere around mid 2017, and we actually started the implementation after the design reviews, etc. The implementation and followed by security review in mid 2018. It took long time for us because along with our day-to-day responsibilities, we actually carve out time for the development and basically all of the implementation tasks. So initially we had two people from Bangalore, two people from US. Overall 4 people that were involved in the project, and we implemented most of the things by 2018 end. We were ready to actually go into production, basically ramp. Initial testing and production ramp in the initial 2019. So I would say it entirely depends on the infrastructure of an organization. We were fortunate enough to have most of the ingredients that we needed. For an example, we already had a solid, Python ecosystem and CI/CD pipelines, very mature CI/CD pipeline, and we did not have to worry about, like, for an example, the monitoring aspect of it. We knew that if we integrate with the existing services, we get the intended result. So depending on what like an organization might have already, that would determine the time to implement. And after the production ramp, we have we have expanded our use cases. We are now working on various aspects, broadening our use cases. For an example, image creation for Azure, etc., etc. So the operational part of it is basically, once we onboard the various SRE teams, are very minimal. We have obviously a very smart set of people, folks in Bangalore and in US as well, that do not require any kind of hand holding. So we prepared a bunch of onboarding documents that would help the SRE teams to learn, let's say, Puppet or the UCM specifics of UCM, how to handle certain scenarios, the FAQs, etc. Once that was done, there's very minimal effort to to like going forward. Our focus would be actually onboarding new use cases rather than the operational and bits of it. That does not mean that we don't see bugs. Obviously, we see we have fixed various bugs while we were onboarding SRE teams. And also we have now semi-dedicated team for configuration management system, along with other infrastructure services, of course, that basically primarily focuses on helping others and taking care of the UCM infrastructure.
Thanks, Sonali. Sanjay, would you like to ask a question live?
Yeah, so I want to know more like how this UCM is helping when where there is a use case in containerized environment and is in cloud. I'm sure LinkedIn will be using Azure, right, as a cloud. So if you don't have to rebuild the image, then in that case, for an existing VM which is running, how UCM helps there, and how it helps in containerized environment.
Right.
Yeah,
So for the Azure VMs, we have once again application specific images, and UCM is actually helping that. We also wanted to include that in the talk, but at the we thought that it would be too much of content, so we did not include that. Probably next year we'll be able to talk about that in much more detail. But basically, what we do, we use UCM to further customize the Azure VM images. Application specific VM images, so that the initial today in on-prem, let's say we see about 20 to 30 minutes of delay between when basically when the machine gets ready for deployment, right? From when an SRE actually requests or submits a machine for reimage, right? So we wanted to cut down that amount of time, obviously, because the VM scale sets in Azure would have to be very, very fast. So with a customized image, we are able to kind of I think on an average, it takes about 5 to 10 minutes, depending on the image, of course, to basically roll out VMSs of 500 to 600 VMs. So basically we are getting there. Customization of images is also one of the big use cases of UCM.
And in containerized environment?
So we use basically, so we have, coming to the containers, we have 2 or 3 different variations of containers. So internally, we also use Docker, as well as we have the LinkedIn specific LinkedIn implementation of containers. But we have not played a major role in creation of images. UCM has not played a major role in creation of images so far. There were initial, basically communication last year, beginning of this year, whether we'd go the container route and basically whether how UCM can help there. But I think so far the decision has been made that we'll use micro VMs in Azure, and the focus is towards that. We have not onboarded any major use cases for containers so far in on-prem.
Got you. Thank you, Somit.
Yeah. So Sanjay, if I may add on to that, right? Let's say at Grab, we kind of again our also internal system is again called UCM. Uh, we run on containers. It's a pretty similar setup as to what Samit spoke about, with some of the differences being that instead of file store and other pieces, we make use of uh, let's say S3 or other such places in different providers, right? So it kind rather than using RPMs, let's say it becomes that hey, which container image version has to be used. I would say that it mostly works. Definitely to the present model, it would need some small changes, but I do not see it as changing a whole lot as compared to what we have, right? And that's a container first setup. So yeah, with small changes here and there, it will this architecture as such works for containers as well at a high level.
Yeah, exactly. Yeah, I agree. I think so.
Yeah. So we have time for one last question, Tripathi. Do you want to go ahead and put your question?
Yeah, great talk, guys. Just wanted to keep it as short as possible. So I think you mentioned that you use Torrent and CF Engine for distribution. Do you still use after you reduced your, the binary to 50 MB? And what can you talk a bit about the infra? How have you set it up? And the second question I wanted to know is, as part of this UCM, how does your developer push their changes? Is it integrated all together? Just give us a little bit of color there. Thank you.
So probably the first question Pawan can take up.
Yeah, so
I'll
I mean,
answer the second.
the CF engine and torrent based technology we used to have in our legacy setup. I mean, since UCM, since we moved to the UCM, I mean, we do not use torrent anymore.
I see.
It's all RPM based installation, like the package installation you do. The CLIs are packaged as an RPM and they are available in the repo infrastructure, and you just need to push the package, like a Puppet has this package resource, so you just need to leverage that and do the installation of these RPMs. So if you have to roll out a new version, you just need to upgrade the package version in the Puppet. So Puppet is the core of UCM. So that's how we do it. I mean, we used to do it earlier using the torrent and CF engine.
I see. So it's no more used. Got it.
No more, yeah.
Okay, thank you.
Yeah, for the second question, whether the software stack, basically is integrated with CI/CD. Yes, we use, so basically we use Gradle, as many of you might know, LinkedIn uses Gradle for building, projects. So basically Gradle is not only building Java projects, also Python and Golang, as well as we have made customization, like basically written a Gradle plugin to tackle Puppet modules. So basically, that plugin would actually run your unit tests. If everything passes, we create a tarball of the module. That tarball is once again obviously version tarball. That tarball is what gets distributed or given to the clients. If depending on the module and all, the specific tarballs are distributed to the client.
Okay. Thanks, Soumya.
Thank you.
Thanks, Soumya and Pawan. If there are any other questions for this set of talk from people, feel free to.
One last question. Just wanted to understand what's next for this system. What's the next set of problems that you guys are looking at? Maybe top 3 problems.
So one of the very important problem that we are basically solving right now is focus towards Azure, preparation of the customized images. So as we are testing in Azure, basically, our focus is on how we can do better on customizing images and how fast we can make. The first set of problem that we face today is the preparation of the images happen in on-prem, but the images have to be deployed in Azure. So there are certain internal issues in doing that. For an example, let's say like the facts would completely change. Whether you are running on a VM or bare metal obviously changes. That creates a set of problem that we are trying to solve today. We are actually trying to build the image creation infrastructure in Azure, right? So that's our top priority. Second top priority is completely replacing CF engine. So today we are running, although UCM is in production and has taken up somewhere around 50 to 60% of the use cases. We want to completely move away from CF engine in the next year. That's a top priority because although we have ensured that if a certain resource is controlled by Puppet, CF engine does not interfere. But there's the system resources, RAM or CPU usage, the demands are there nonetheless. So we want to ensure that we clear it up such that the applications that are supposed to be deployed and running from those machines, they get the system resources. So that's two of our top priorities for the next year.
Thanks, Soumya. So yeah, for any other questions on this particular topic, folks, feel free to put in chat, and we'll request the presenters to take it up offline separately in the Meetup forum. Time to move on to our next session. We have Rahul and Vijay from Verizon Media who will be talking about GRU. the resilience testing framework at Verizon. So Rahul and Vijay, over to you.
Thanks, Anshu. Am I audible?
Yep.
Okay.
Pawan, you want to stop sharing?
Pawan, you there?
Hey, yes, give me a minute. I'm just looking for the option to stop the share.
Should be at the top of your screen.
Just a minute. I'm just quitting it. I'm not figuring out the option.
Yep. Okay. Thank you.
Yeah. Good afternoon, everyone. First of all, let me thank you for joining the session. In this session, we'll be talking about the approach we took on improving our product or a system's resilience within Verizon Media using a tool we recently built, and we call it as Groove. Next slide. Can others mute? There's some disturbance. Yeah, thank you. Yeah, let me quickly introduce ourselves. I'm Rahul. I have been working with Verizon Media for about 4.5 years as a software engineer. I have experience in production engineering and recently some product development as well. My interests lie in working with distributed systems and increasing the availability for those. I also have Vijay with me. I will let him introduce himself. Vijay.
So hi, my name is Vijay. I've been working with Verizon Media for past 1.5 years as a software dev. I mostly work with front-end and back-end technologies. Yeah.
And we also have some of other members from our team in the Zoom session as well. Yeah. Next slide. Yeah. So let's go look at the agenda we have planned for today. First, we'll go over the background on why it's important to test resilience of a system. Then we will briefly touch upon the chaos engineering principle. Then we'll talk about Groove, its design, and some success stories we have had it with some systems in Verizon Media. And then some future plans for this tool. Next. Let's go over some unexpected failure scenarios which can happen to a system. Let's say there are some configuration errors which may not have all scenarios thought about as the product has evolved. For example, let's say there were some auto-scaling policies which were set up when a system was initially designed, but now it has been outdated with some new changes to that system. Another scenario which can happen is some system failures like network DNS or any upstream or downstream system failures. So for this, let's take the example of a network switch going down. So when a network switch goes down, some servers might be connected to the switch. So how do we know how our system is going to behave? Yeah. So how do we know our system is going to behave? And how can we ensure it recovers quickly when the network switches back up? Then there can also be misbehavior of any external systems. So many things can go wrong to a system in production. So with all this, it is difficult to predict how a system behaves when unexpected failures happen. And especially when it's a large-scale distributed system with hundreds or thousands of servers distributed among multiple data centers.
Next. So what do we need? So no system is designed to handle all unexpected events. But by proactively testing how a system responds under some control failures, we can identify and fix potential issues before they occur. We can improve the incident response time. And eventually, with all this, we can build more confidence on systems resilience to real world failures. So, with all this, we needed a system that can help us measure the resiliency of production systems against unexpected failures. Next. Yeah. So in the process, we started listing down some key requirements for this tool. Let's go over them. So first one was failure testing has to be continuous and automated. It has to be continuous for a constantly changing product because it can't just start and finish on one day. And for that matter, it has to be automated as well. And we should have an easy and reliable way to inject and test system failures. And we wanted this easily integrated with our open source CI/CD tool, which is called as Screwdriver. And coming to the next requirement. Next requirement was it should be controlled and monitored. At any point, the failure testing should be done on a small experimental group, which will have a small percentage of servers. And during this failure testing, we should be able to monitor how the system behaves. So for this, we wanted it to be integrated with our in-house monitoring platform, which we call as YAMAS. Next, so now coming to the next requirement, the tool should provide for a secure way to test. So within Verizon Media, we use, hello. So within Verizon Media, we use our open sourced project Athens for all kinds of service authentication and fine-grained access. So we wanted this tool to use Athens for those purposes. Next slide. Yeah. Continuing on the requirements. Next one was it should meet all recommendations from our security team. Then it should support both on-prem and public cloud infrastructure. And this tool should take minimal effort by the system owners for integration. And then last one is the system owner should have complete control on the testing. So here we preferred the self-hosted model instead of the centralized model. Next. Yeah. So chaos engineering is all about building confidence in a system's ability to handle unexpected failures in production. So let's go over what this involves. So first, if you see on the top, first we have to define a steady state hypothesis. So this can be, let's say, for example, stating that my API's latency will remain within X and Y threshold in spite of experiencing certain failures. And once we define this steady state, then we create an experimental group with a small percentage of servers. And this group is where we will inject the failure. And the remaining control group remains intact. And then we ensure that both of these groups are in steady state to begin with. After we ensure, did someone ask any questions? Okay. So after steady state is ensured in both groups, we then inject failures in the small experimental group. And then we monitor that how if the steady state hypothesis still holds good for the experimental group. And if it no longer holds true, make changes in the system and repeat this process again and again to make systems more resilient. So let's say if the API latency has breached the steady state thresholds which you are defined in the steady state hypothesis, you make changes in the system to make the system more resilient. So based on the chaos engineering domain, there are some really good tools available in the market, both open source and vendor provided. But since we had some very specific set of key requirements, we decided to come up with something in-house, which we call as GRU. And now Vijay will take over and explain how GRU is designed. Over to you, Vijay.
Yep. Thank you. Can you hear me? Just.
Yeah, I can hear.
Okay. So what it is? GRU is a chaos engineering toolkit that we have built to test the resiliency of a target system running on on-prem or AWS in a controlled manner. So GRU adheres the core principles of chaos engineering like steady state verification, where we verify if the target system is in a stable state before creating chaos, and chaos on an experimental group in a controlled manner, and check if the steady state criteria holds good during chaos. Based on the requirements we mentioned earlier, GRU has an integration with Athens and for authorization and authentication, and with Screwdriver, which is our CI/CD tool, and Yamas for monitoring. The tool has the capability to create unexpected behaviors like spike in CPU utilization, disk volume full, create network connectivity issues, and dependent failure systems. And it designed in a modular fashion to support additional use cases as well. So what it isn't. GRU is not a load testing or functional testing tool. The issues found while failure testing is not automatically addressed by the tool. Rather, it helps to reveal the failure points and lets the system owners come up with the appropriate fixes. GRU does not increase the attack surface for abuse because it's a standalone tool and it's controlled by the system owners completely. So GRU has three major components: the test plan, the GRU, which is the orchestrator, the minions, which are the attack scripts. The test plan is a structured document which can be written in JSON or YAML, and it is created by the property owners, and it contains information like host list, a list of hosts on which the attack will be performed on. If the target system is in AWS, then the test plan will contain AWS region and tags. GRU uses this information to query AWS to get the list of instances on which the failure testing will be performed on. Next is the blast radius, which helps us to define an experimental group. For example, if we have 100 hosts or EC2 instances in a target system, setting a blast radius to 10%.
Yeah, and others, can you please go on mute? There's a bit of disturbance from me. People are not presenting. Thanks.
Yeah, like I mentioned, if you have 100 hosts and in a target system, setting a blast radius to 10% helps you to pick random 10 hosts as an experimental group. Then we have the list of minions and its config. For example, a CPU burn minion has a duration property on which we tell how long the CPU spike should be created for. A block port minion has a duration property and it needs a list of ports to block as part of config. Next, we have steady state definition. The test plan will contain a list of metrics and steady state and chaos state criteria. During the steady state verification, the metrics specified in the test plan will be fetched from Yamas and verified against the criteria specified in the steady state verification. These are some of the important fields in the test plan. We have a sample test plan in the coming slides for better understanding. The second main component is GRU, the orchestrator, which is built as a command line interface, which takes in a test plan, verifies the test plan, and orchestrates the attack. Once the attack is complete, GRU rolls back the changes done to the host and generates a test result. GRU also copies the log files which were generated during the attack back to the Screwdriver job. Next, the third main component is the minions, which are the independent scripts which perform the attack on the host. For example, a CPU burn minion, or a disk fill minion, or a port block minion. Next, we'll go over the implementation of this. The system owners come up with a test plan detailing the necessary information to perform the failure testing on the target system. The test plan then is passed to GRU. The GRU tool checks if the target system is in a steady state or not by verifying the metrics against the threshold specified in the test plan. If the test plan is not in a steady state, the attack is aborted. If the test plan passes the steady state verification, then GRU connects to all the hosts and performs the attack as configured in the test plan using the minions. Once the attack is complete, GRU generates a detailed report for the system owners and performs a cleanup on the target system. It also monitors the metrics to verify if the system came back to the steady state after the failure testing is complete. We have a sample test plan here. The test plan has three major sections, which is the minions, the target systems, and the steady state verification. So the minions have some of the important properties like execution mode, like telling that the system should run in a sequential or a concurrent mode. And we have the minions like CPU burn and its configs like duration. Next, the target system. It has some of the Athens related properties as well. If in case of AWS, it has a region and a tags. And we have the blast radius as 100%. Next, we have the steady state verification where it has the list of metrics and filters like the request status must be 200 and which endpoint. And the steady state and chaos state definition. Where for example, in this case, we have configured a CPU burn to run for 120 seconds with 100% blast radius. So the GRU checks if the latency of the target system is between within 1 and 6 seconds for steady state verification, and if the verification passes, the GRU starts the CPU burn on the target systems. During the burn, the chaos state is checked, and it states that if the API latency is between 1 and 10 seconds, then the chaos state verification is successful. After the attack is complete and the rollback is done, we again check if the system went back to the steady state and the API latency is back to between 1 and 6 seconds. So this is a sample test pipeline for the CPU burn. Since this is a sample test, we have generating the traffic manually. So first thing the GRU checks is the steady state verification and checks if the target system holds good the steady state criteria. After this, the attack is performed on the target systems and chaos state criteria is verified. Once the attack is complete and the rollback is done, we again check if the system went back to the steady state or not. So let's go over the Minion designs. Minions are the Python scripts which will be used by GRU to create chaos in the target system. Each minion follows a set of common interfaces like setup, run, teardown, and get status. Because of these common interfaces, it's easy to design a new minion and integrate with GRU. At present, we have some of the attack minions that we have are CPU burn, disk fill, a block port, block traffic, and block DNS. For example, we can use a disk fill minion to fill a disk volume till a given percentage with junk files. Or we can test the auto-scaling policy using a CPU burn minion. A traffic block minion can be used to simulate a dependent system failures by redirecting the request sent by the application to localhost. We also have two validation minions, the cert validation and SSL validation minion. The cert validation minion checks if the target system's X509 certificates are valid for 7 more days. And the SSL validation minion validates an endpoint's SSL cert is valid for 7 more days. Next is the security. The system owners will have full control over the failure testing pipeline, like which test to execute during what time, SSH access to host, and the GRU, what all access roles the GRU gets. GRU also adheres the Verizon media standards such as SSHCA, short-lived credentials, and no keys or credentials are stored by GRU, and no data is sent to the external system other than YAMAs for monitoring. Next, The success stories. We have integrated GRU with some of our products and used cases like a single node failure, a multi-node failure, or entire data center failure. And some of the properties have identified a bottleneck in the data migration that they had, and also there was unexpected server timeouts when a node came back to the cluster. So going over the future plans, we have planned to improve the random execution of minions in GRU, where we select a random minion from execution from a list of minions which were specified by the system owners to perform the failure testing. Next, a schedule execution of minions. Since failure testing should be a continuous process, we wanted the ability to do failure testing in a cron job fashion, where we trigger a test once a day or once a month at a specific time. At present, we support targets system running in EC2 or VMs, and we have plans to support systems running in Kubernetes or AWS Fargate clusters. And improve test results, where we want to generate a single consolidated report which will contain detailed information on the attack performed. And exploring AWS SSM chaos. We are exploring the advantages of using SSM agent to perform the failure testing in AWS. And we also have plans to open source GRU in the coming days. Yeah, if you have any questions.
Thanks, Vijay and Rahul. I think one question from my side would be, do you guys account for databases latencies or databases going bad? How do you do it?
Hello, can you hear me?
Hey, yep. Are you able to hear me? Hello?
Okay, what was the question? There was some breaking.
Yeah. So, do you account for databases, latencies, database issues? How can GRU help on that?
So it's left to the product owners, like a DBA team can integrate the GRU tool in their system. And we have a port block minion which can block all the SQL ports or Oracle ports and simulate a outage of DB. And
I would like to add on that, like from a product owner's perspective, what product owner needs to do is he needs to identify the key metrics of a system. So let's say if it's a DBA team, they would come up with this metrics which they are interested to monitor during this failure testing, and they can list out those metrics in the test plan. So yeah, our only requirement is that these metrics should be exposed in our in-house monitoring tool. And when GRU is running, we will fetch those metrics, and based on the criteria set forward by the system owners, we do the failure testing and give out the result.
Yeah.
So in the end, it's up to the system owners to come up with the failure testing plan. Yeah. Does that answer your question?
Yeah, that definitely helps. But the one question was around, let's say, databases latency, right? How would does the system help to introduce database latency, or how can the system help to test for cases where the DB is not hard down but is seeing higher than normal latency? How can this help?
Right. So right now, I believe we don't have a minion. So minion to add the packet drop to the IP tables rule to. So one way to introduce this latency is to add packet drop rules to the IP table filter. And but what we right now have is like we can block a certain endpoint from a system owner's perspective. Let's say your system is depending on some database, and if you want to block connection to that database, you can do that and see if it's recovered, how quickly the system recovers.
Yeah, on the latency that you mentioned, we can run a CPU burn on the DB host itself, And this causes the query to execute slower in some cases, and we can simulate, I guess, that.
Yeah, I'm sure. I think we have not yet tested this against a database system. Okay, so probably the other system that we have tested is not with any storage as of now. I mean the database one.
Got it. Yep, sure, definitely. Thanks, Shanuga. So yeah, that would be an interesting one, right? Yeah, so network level pieces, yeah, will work for application stacks, but yeah, for DBs, I think we'll have to think a bit deeper. So yeah, okay, all right.
Yeah, sure. Yeah, sure. Thanks. We'll look to implement it. Yeah.
We don't have any other questions on the chat. Folks, feel free.
I have a bunch of questions. I'll maybe I can go one at a time.
Yep, sure. Please go ahead.
Yeah, the first thing was I'm assuming this is being tested against a dedicated setup, right? You're not really testing against a prod setup.
We can test, but at present we are testing on only the QA environments.
Got it. So no, when you say end-to-end environment, what do you mean? What I meant was if you are taking a prod setup and testing against that, then you would probably want to separate out your monitoring data from a point of view of saying this is actual prod versus this is painted from a test point of view, or something like that. Whereas if you have a separate dedicated setup, then all the monitoring data over there is purely from the test point of view.
Yeah, for
of
this,
course,
yeah, go on.
Yeah, to continue my thought, there is the cost of maintaining a dedicated setup for just for chaos testing, right, or any other form of testing.
Okay, Rahul, you want to take it?
Yeah, I can take this one. Okay. Yeah. So right now, at least the products within Verizon Media, right now we are the products, the initial products. What they have done is they have a separate dedicated setup for this. So the advantage with that would be definitely that it won't interfere in the production metrics, or it won't do any actual damage during the traffic. But eventually we want to get to a state where this attack is done on a production system, but it should be done on a time when engineers are around. And on the question of separating out the metrics, so like in the tool I mentioned, we will be running this against a set of machines, right? So while we are querying the data from the monitoring tool, we can filter out the host which we are interested on and see how it's performing. And we can also look at how the system in whole is performing. So both cases have their own, advantages and disadvantages. And one more advantage about running on a production system is in a dedicated cluster, it may be hard to mimic the exact configurations of production system. So you miss out on that aspect when you're running on a dedicated system. So I guess the eventual goal should be we should be comfortable with both. Does that help answer your question?
Definitely.
Yeah.
Sure. Yeah. I can go on to my next question. So I understand that the target system right now is basically a single app or a single service, right? So if in that case, do you have a way to create a target system that probably spans multiple services or apps? Basically, what I'm getting at is if I want to do chaos testing or rather understand chaos testing at a business functional flow level, let's say in an e-commerce product, that means let's say I'm checking what does it mean to do chaos testing in my order processing flow or order placement flow, right? So that would probably mean it's a collection of microservices or a collection of disjoint apps that are participating in that flow.
Right.
Yeah.
So you want Yeah, good, Vijay.
So while running the chaos testing, we don't consider the application as such. We just need a host. You can list any host you want, and we perform the attack on that host as long as we have access to that. So you can configure your all the microservices host in that list, and we can say what minions to attack to perform on that.
Roland. So if you take this is something like you pass a list of host, okay, to or list of host, to, and then a list of services, or if you have what is it? Okay, you'll have to give the configuration or run the pipeline against number of services that you are planning to run. Okay, so it takes a set of hosts from a list of hosts that you give, and then the attack is done against those hosts. So if you have multiple services within your service, then you'll have to run each and every, different pipeline for all those things.
Understood. So any reason to choose a physical entity like a host for the target? For example, with containerized environments where your infra can keep moving, or rather the deployment can keep moving, would it make better sense to target a app or a service rather than the underlying infra itself? I mean, eventually, yes, it would be implemented as a attack, as you say, against a infra component. But from a specification point of view, would it make better sense to specify a logical entity rather than a physical entity?
We haven't given thought about it. We'll consider that. Yes.
One more thing here was like our initial onboarding we had. That use case was a bit related to a host level thing, and I think this also made the onboarding a bit faster in that case. But we do have plans in coming quarters to see how to address the container workloads more effectively. Does that answer your question?
Great. Yeah. Thanks.
Any other questions?
It would be also interesting to if anyone can share if they are doing some kind of failure testing at their company.
Yeah, so I think Chaos Monkey from Netflix is what comes to mind in terms of existing tools, right? That's something which we have been experimenting with, and that clubbed with, let's say, a Kubernetes kind of setup makes it, that's something which we are exploring and then figuring out further to see how we can integrate it with real-time testing or as part of the CI/CD framework itself, other than the usual testing. How can we have Chaos Monkey testing also involved in there? I think that's what we are working at. But yeah, would definitely love to more about others.
You have something
Thank
internally.
you, good to know that. Yeah.
So I was just saying that we have something internally at LinkedIn called Water Bear that we use for chaos testing, but it's not yet open sourced.
Yeah. So yeah, thanks Vijay and Rahul. Interesting talk. So yeah, for folks again, any questions you have that you think afterwards, feel free to put it in the meetup forum, and then we can will request the presenters to answer it over there.
I have one question, because I was just going through the slide and the area we use cases we covered for the host testing. Have we designed and tested some of the region flow, data center region flows, like AWS region flow use cases?
Yeah, so in those use cases, what you would do is like you would specify the region in our test plan, and you will increase the blast radius. So when we fetch the instances, we'll end up fetching all instances from that specific region. And in case of on-prem, yeah.
So how quickly that covers the system back to the normal? Did you measure the time with how quickly the system can come back on serving the production workload?
How quickly the recovers? Is that your question?
Yeah.
Yeah, so that can vary, right? So that's up to that system's architecture and how that system is responding to those failures. So the idea here is how that system owners can do these attacks and see how quickly that system recovers. And if it's not recovering faster, then take steps themselves to make this more resilient. Does that answer your question?
Yeah, that makes sense. Thank you.
Yep. Thanks, folks. Yeah. So before while we proceed to the next one, right? Devanshu has joined us. Devanshu has been one of the initial, if I may say, co-founder for the LSP India group, and has been running it with the help of, and has been helping all of us in organizing and joining this on a regular basis, right? So yeah, Devanshu, would you like to introduce the next set of presenters, and we can maybe talk a bit more post that?
Sure. So sorry, guys. Like some glitches at the morning, so I requested Anshu Vinny to take over and run the show. So yeah, I think our next talk is from Raghav, and interestingly, the trend now is doing more secure stuff, and that's where the DevSecOps been interesting. Then if you look at Puppet Labs, DCS, the DevOps status of DevOps report, and that also starts with security in mind. So I think it is high time that we get into some discussion around security integrated into our development and testing framework. And from that background, I will request Raghav from Thomson Reuters. Interestingly, he is our remote speaker today. He is working out of Hyderabad, so he would be joining us. Raghav, over to you.
Thank you, Devanshu. Am I audible clear?
Yes, you are.
Cool. Thank you. So good afternoon, everyone. Thank you, LSP, for giving me an opportunity to speak and present on this topic. And thank you all for joining. Today I'm gonna give a quick introduction of embedding security into DevOps, which is the trending buzzword called DevSecOps. And myself, I'm Raghav Bichula. So I'm lead DevOps engineer at Thomson Reuters. And my core responsibilities are to design and implement deployment pipelines for the various tax products developed at Thomson Reuters, and also responsible for the resiliency of those applications hosted in the cloud. So the agenda would be like brief intro about DevSecOps, some principles, and I will be doing a few open source tools in between few areas where security is needed. So most of the companies must have started their journey into the cloud probably 5 years ago or a decade ago. Like basically, as Thomson Reuters, like we recently started moving our workloads to the cloud, mostly AWS and Azure. So prior to that, we would have dedicated teams in the data center. We would have infrastructure provisioning team and a security team having their own responsibilities, and we would have some stringent policies for getting an approval to open something outside or letting something in from the outside when we were in data center. So when we started moving to the cloud, so as end users, we got lots of control on such stuff, and then security kind of plays a major role, and it should be handled correctly when we start hosting things in the public cloud. So generally, when we start speaking to our customers about our product or something, so basically they kind of say, if the application is hosted in the cloud, so they kind of become a little bit skeptical about the security first and the other areas like resiliency and other stuff. But so as a cloud provider, if it's AWS, Azure, or Google Cloud, so they're responsible for security of the cloud, including the hypervisor hardware, the data center protection, and other stuff. As end users or customers, we are responsible for security in the cloud, like whatever we are provisioning and whatever we are configuring at the entry points. So we should be careful enough and design in such a way that they're capable of capable of handling these attacks or hackers. So we all know DevOps, most of the companies have already adopted the agile and methodology and DevOps. There are dedicated DevOps teams for products, and DevOps is the modern way of delivering applications faster and with higher quality to meet the needs of the business. So things are going smooth, but when we enter into the cloud and opening things wide, so then starts the blame game. So if something goes wrong at the production level and there's a breach or something, so then the security team comes and points us at the developers or operation teams, saying that you guys have done this and that caused the breach, and yeah, this thing happens. So then comes DevSecOps. So DevSecOps in the cloud, it takes an approach to security, and it builds security into your deployment and operation process, and it's a way of adopting the security mind in everyone's mindset, using it in as early as possible. So like we say, so security now should be shifted towards the left when we look at the development cycle. So previously, we used to run some security scans, whatever we do as part of release cycle. So they used to happen at pre-prod or production stage. So now, since most of us are hosting in the public cloud or going for the managed solutions, so the security should be started from the development stage itself, and it should be adopted as it should come as a mindset in every member of the team developing the product. So as I said, the the effort is to strive for secure by default. And so there are some of the principles of DevSecOps. So we need a good culture between the different teams, developers, operations, and SecOps teams. And without this culture, and if there is no good friction between those teams, and DevSecOps doesn't go good. And there should be mutual collaboration and between the developers and operations to make this as a practice, and always promote cross skilling. Like, so developers need to know what operations teams or security teams is knowing, and vice versa. So operations teams or the security team needs to know what's going in the development area as well. So it's like building a good harmony between the teams makes the DevSecOps a successful implementation. So how do we take this forward? So so this is a sample pipeline. It's not like hard and fast rule to follow this, but a simple pipeline to implement DevSecOps. So starting from the development stage to the production. So at various stages, we can install security as a practice. Like when it comes to development stage, we can have plugins or pre-commit hooks to perform some checks, like detecting secrets or tokens in the code base, and using secrets management to store the secrets and pulling them wherever required. And during the build stage, so we can have different type of testings, like penetration testing, application security testing. So there are a lot of tools available. So, and we can also have a dedicated vulnerability management pipeline. So whenever something is detected, so to mitigate that immediately, so we can have a vulnerability management system that can basically take the defect and take the input and mitigate it, and so that it doesn't occur the next time. So proceeding further, so as I said, like, so security should start from the development. So most of us like have so in a hurry or like to complete the given assignment. So sometimes we tend to use hard code the secrets in the code base. So even I did once when I started using GitHub for the first time. So I committed my personal token to the GitHub, and so GitHub basically has some crawlers, and which immediately sent me a notification saying that you need to revoke your key because like you have publicly committed it. So I mean, like, since it's GitHub key, so GitHub was able to get back to me and say that, okay, you have done this, but what about other application keys? Like if it's AWS or Azure or any other integration token. So I mean, some of them might have some crawlers and get back to you saying that this, and they may be able to segregate and say that this belongs to this account, and so and so person is responsible. So they can come back, but I don't think most of the providers does that. So it's good to have a mechanism to stop or detect secrets before committing them to the version control systems like GitHub. So to accomplish this, so there are a wide variety of tools available. Some of them are like Talisman, Detect Secret, Sneak, and pre-commit hooks we can add a configuration to basically add wide variety of tools using pre-commit. And some other tools like Truffle Hawk and Defect Dojo, they can basically track the vulnerabilities or the defects that have been detected during the checks. And recently, GitHub Actions has also got integration to perform all these checks. So I'm going to show a quick demo on how to perform this. Okay, so I have prepared a repository, a sample repository to demonstrate this. So it's called Python demo project. It basically have some scripts here. So when setting up pre-commit hooks, so you can basically configure a file called pre-commit config.yaml. So in which you basically specify the tools which you want to use to scan your code base to detect secrets. And so one thing important here is like, so you need to basically ask developer to run this setup.sh file before he starts working on the project and starts committing it. So because like this is a prerequisite step for the pre-commit hooks to work in Git. And once we have this ready, so let's say like I have a script called demo.py. Here, like you see, I have specified a token in the script, and start committing it. So the pre-commit hooks comes into action, and so they basically doesn't allow to commit itself, and it says that there are secrets in the code base and they need to be fixed, and then you can commit it. So this is at the developer level. I mean, like, let's say, for instance, a developer forgot to run this setup.sh, and so since this was not run, the commit hook was not configured, and he can able to push the secret, right? So we can handle this during the, I mean, once he pushes, like we have the pipeline triggers where the code has to get built and deployed, right? So we can handle it at the pipeline level as well. So if I go here, so GitHub basically, as I mentioned, GitHub has recently added this actions feature where you can pass in some custom actions to be run before. Actually, if you have a code base from a branch or something, so we can have those checks, and once the check passes, then we can merge into the actual production branch. So in workflows, like I have added one workflow where to run some secret scanning for the code base. So it's the same app tool, detect secret. So if the developer commits this token into the code base and he bypasses the pre-commit hook since it was not configured, so this can catch it, and it can basically make the pull request or the next step in the pipeline fail, saying that there's a secret and it needs to be fixed before proceeding further. So in case we don't have GitHub, so we have another tool called Truffle Hawk. So I think I missed out installing the tool, but never mind. So basically, Truffle Hawk basically generates the same structure here, which you see with the commit ID that has the secret, and so that can be uploaded to an open source tool called Defect Dojo. So Defect Dojo is a project from OWASP's Open Web Application Security project. So there are a lot of wide variety of tools available in their portal. So Defect Dojo is one of them. So you can basically upload the file output generated by Truffle Hawk to Defect Dojo, and it can basically show the findings here. So if someone does that, so it basically shows what strings are found and what's the commit hash and everything. So this can be also used for the compliance sake to keep track of the number of vulnerabilities found during the code base scanning. So it also comes with API because in the pipeline, so we can't do a manual upload or something, right? So it also has an API where you can submit this Truffle Hawk scan report and retrieve the scan result, and based on that, you can proceed with the next step in the pipeline. So that's about the code, detecting the secrets and scanning for the secrets in the code base. Any questions before proceeding further? Okay, so since we don't want to have secrets or tokens to be committed in the code base, so we need to have a centralized solution for the secrets. Yeah, so it's always hard coding. So there are a lot of tools available, open source and proprietary for the secrets management. So even the cloud providers have come up with their own solutions, like AWS has AWS Secrets Manager, and more or less it's similar to AWS. So Azure also has its own secrets management tool called Key Vault, and the popular tool in the open source world is HashiCorp. So with HashiCorp, like you can have multiple backends, like based on the cloud provider. Like if you want to use HashiCorp on AWS, so you can use DynamoDB as a backend. Or if you want to host HashiCorp in the data center, you can use Console or PostgreSQL as a backend to store the secrets and retrieve them programmatically as well. And HashiCorp also has good integration with the clouds. And it also has got one-click launch deployment. I mean, you can quickly launch the stack and get it working out of the box. So similar to HashiCorp, there's also called Taurus. And Thycotic Secret Server is also one of the popular secret management tools. So it's basically Windows-based. I mean, it runs on Windows, and the programmatic interface is not that good. So it basically dumps everything in XML format, and we again need to deal with XML and retrieve the secrets. ENVKey is also one of the popular tools. So next comes the container security. So like, so we have these containers evolved a few years ago, and we are now with Kubernetes and service mesh era now. So like how we perform the scanning for vulnerability scanning for operating systems. So even containers need image scanning as well, and they need to be fixed and mitigated before they reach the production. So there are few tools available for container image scanning as well. So one of the popular tool is Cli. This was acquired by Red Hat, and it's embedded in AWS Elastic Container repository. So this is basically similar to Docker Hub, so where you can host your images, container images. So Cli has got a good caveat database of the latest vulnerabilities. And similar to Cli, there is a Snyk. Snyk is also a popular tool in DevSecOps area. Like it has multiple things under a single place. So it can do a secret scan in the code base. It can scan containers. It does a lot of things. I mean, this is again a proprietary solution. You need to purchase the plan to explore more features. The other open source tools are DocScan, Dartga, and Anchor Engine. So basically, with open source tools, so you need to maintain the infra for hosting these, and also make sure that the caveat database of vulnerabilities is updated to the latest to ensure that you're always up to date. So some of the best practices to build a container image. So try to choose the minimal source image. So this basically reduces the layer count. Instead of choosing a readily available image from a specific provider. So if it's simple to install the tools of the provider, it's always best to choose the minimal source image, and perform upgrade to update the libs to the latest. Some preferably say not to do that. Sometimes it increases disk size, but it's up to you. Like if you want to always stay on the latest libs and you don't want to have any vulnerabilities detected in the scan tools, so it's good to stay updated. And the most important thing is never ever let the entry point of the container run as root, and try to create a least privileged user and run the application accordingly. I used to do this when I started building containers, and later, I mean, I saw a lot of people addressing this, and so I immediately changed my mindset and started creating users in the container for the applications. As you know, like root can do anything if it's prone to attack, if the container is prone to attack. And avoid installing unnecessary packages, and don't forget to purge the cache at the end. So basically, install whatever you need for the application to run in the container. I mean, like there is no use to install a bunch of packages and increase the image size. And when installing anything from the pip, yum, or apt, so it basically dumps some cache on the disk. So either remove them by doing RM, or there are tools like yum purge cache or apt purge cache. So you can purge the cache to save some space, like disk space. And don't leak sensitive information to the containers. Like, so when you recursively copy some directory structure, it might have some sensitive information, so which is not intended for application if it's hosted, if it's public facing. So it's a good practice to use Docker ignore file to exclude such patterns, and try to use copy instead of add, because like if you use copy, you will selectively copy specific files, and whereas add, you recursively copy the entire directory structure, which sometimes might have sensitive information. And I'm a big fan of linting tools actually. So every time I write a new script or in any platform like Python, Ansible, or so I do a lot of linting before testing the stuff. So it basically gives suggests good code practices, and also the next person who is going to take the responsibility of tool, he will have a good readability. So try to use linter, like Docker file has also got a good linting tool called HadowLint. So it basically suggests some good practices and predicts like if there are any syntax errors or if you're using some additional unnecessary commands for building a container, it predicts it. And to add an additional layer to protect the images, so based on the cloud provider, so you can also encrypt the images to add additional layer. It's like AWS has a KMS, so with which you can encrypt and probably assign specific role to which is capable of decrypting that image using the KMS key. So this way, none other users or applications which are not authorized can basically pull that image. So time for another quick demo. So as I mentioned, like, we need to try to choose the minimal image when building a container. So let's say, for example, like I want to build an application with Node.js as runtime. So Node has its own container images available on the Docker Hub. So I mentioned like, so to build the container image. So I specify source image as Node long-term release, and I just copy my index.js and start the application and build the image and push it to ECR. So let's see what happened in ECR. So the version 1.0 you see here is from the, when I choose the image, source image as node from the node. So you see, it had like basically, okay. So it had these number of vulnerabilities detected by ECR scanning, which is Cli again in the backend. So we never know, like these guys, they periodically keep the image up to date and perform scanning in the background to ensure that they are not prone to any attacks. So some of the providers does that, but yeah. So to overcome this, so as I said, choose the minimal image. So I have chosen Amazon Linux 2 as my base image. And now I want to set up Node.js, right? So I just want to install the Node.js binary. So I'm just downloading it, the specific version of Node.js. And once the setup is done, I'm just copying the code and running the application. So when I push this to Docker Hub, AWS ECR with tag 1.1, so there are no vulnerabilities detected. And added to that, you can see the reduction in size. So this was close to 360 and this significantly reduced. So this might have some unnecessary packages which you don't need for a basic Node.js application to run. So the size also matters, like when you have auto scaling configured for your application. So the cold start to start application. So basically the Kubernetes or if it's ECS Fargate, whatever your container applications are running on. So they basically need to pull the image, right? So the size also matters when you want your applications to bootstrap fast and pick up the traffic. So it's not only with Node.js, you can also do the same with Nginx as well. So even you can have Nginx installed by choosing base image as CentOS or any other operating system like Ubuntu. And if it's a basic package, it's best to choose minimal image and install the software or the application, and then proceed with the configuration and then start the endpoint. That's about container security. Any questions? Okay. So proceeding to web layer security. So let's say like you have a server which is going to be public, whether it's any cloud provider. So the moment you start it, so we have the problem with the port scanners, bots, and everything, hitting it with random number of random requests, junk requests. So sometimes like it might cause performance issues with these scanning tools. So to mitigate that, so we need an additional layer for the web layer. So sometimes like we can choose we can choose and apply open source solutions, or else if you want to offload that to the cloud provider, there are solutions available for that as well. So AWS has this popular service called Vav Web Application Firewall. So where you get 1500 web capacity units when you set up firewall for the first time, and you can choose the predefined rules and also add custom rules as per your requirement. There are also other proprietary tools like F5WAF, Nginx, Protect, FortiWeb. And as I specified, OWASP has also got a lot of projects in this area. So it has its own solution called Web Application Firewall. So even if we have these firewalls configured, so the bots are still intelligent enough and they're not going to leave the server. So you see what happens. Yeah, so they're still going to reach the server and run their payloads. So, I mean, in my project recently, which I've been working on, so even if I had WAF configured with some, I mean, it's not that stringent with basic configuration. There are still some requests like these which have bypassed the WAF and entered the web layer. Basically, they reached the load balancer till the Nginx. We basically run our workloads on Nginx in the web layer. So they reached Nginx, and so this is how they get in. So I had to do some little bit of config tweaks to mitigate this. So Nginx proprietary edition has got one interesting module called authJWT. So where you can allow requests which have the valid authJWT token, and then let it proxy pass the request. Or else, like, basically you can whitelist your IP address range of the VPC or the data center and allow the traffic and deny the rest to block such requests. So there are some of the known fixes. There are some tools available as well, like Nginx bad bot blocker or perimeter X Nginx plugin. There are plugins available as well. So, or else you can, if you are still concerned, you are paying for the firewall, and you can work with the provider to apply stringent rules to block all these, provided they meet the web capacity units or the limitations of the firewall. So the final motto is like secure all the things from the development phase. It's always like we should have shift left my approach when adapting the DevSecOps, and empower development operations deliver better, faster, and secure instead of blocking. And few references which I use it to create the demos and slides. In time for questions.
So Raghav, very well organized, very well organized. Thanks for talking about this. The references are pretty interesting, and you covered the different aspects. So the thing is, have you deployed these practices in your workplace with some results seen before and after? Do you have any case studies, or even not case studies? Probably those are corporate NDA. You can just talk about those, like how it used to be before, how it is after adopting those practices now.
So the practices, I mean, like the areas which I have mentioned. So I haven't implemented all of those, but actually I'm moving into a new project where I'm going to definitely implement. But in my previous project, I have implemented some of them, especially the container image scanning. I have forced it, and I added a step before the pre-prod or prod deploy to ensure that the image which is going to prod has passed all the checks by doing a check from the ECR to ensure it doesn't have vulnerabilities. And the web application firewall as well. So I added it in my previous project, and it kind of helped us to understand what sort of requests are coming in. And we had a lot of clients consuming the API services. So we had to allow some pass in some rules to allow some specific payloads. So that kind of helped us to achieve some part of DevSecOps, not all. And these are only some areas. Like there are a lot of other areas where you can implement. I mean, other lot of tools and areas. Like for instance, if you host application and you want to check the TLS protocols or the cipher suites. Basically, we have the quality scan, right? So you can also add a layer to do that before announcing it to the customers.
Okay, so my second question is, when you are introducing this new set of checks,
yes.
Have you seen resistance? Like DevOps, the one part of DevOps is the culture.
Yes.
So have you seen a resistance, or in general you have seen acceptance with development colleagues or the engineering counterparts?
Yeah, that's a good question actually. So the current team I'm working on, so we really had a good harmony. So we didn't have any resistance. So I understand like there will be definitely resistance because developers' time is very expensive and they need to focus on the product stuff. But this is also important, right? So maybe, yeah, it depends on the team actually. So the team which I'm working with, I didn't have any silos, so it worked well.
Thanks, Raghav. I'll open up to others for questions more.
Yeah, and to Devanshu, just to add on to a bit to your last question, right? I think we do similar practice. I think what I would put in is coming in early helps. So like similar to what let's say Raghav was saying was right. If we don't have much of baggages, then it becomes easier. Yes, but if you have baggages, then any changes, whether be it on DevSecOps front or be it otherwise, they definitely have their inertia. So yeah, working on newer projects first and then backporting to older projects may help. But yes.
Yeah, thanks, Anshu, for sharing your experience. Anyone else have any other questions? DevSecOps is going to add, like, for new companies and smaller companies wherein the feature matters, security comes later. I think this could be a nice starting point, and that's why the whole of the environment is talking about additional security. Because I was doing a security talk probably in July, August time frame. So there, while I was gathering material, uh, so during COVID, like security was at a tremendous, the heightened state, and I'm not very sure. Probably every company who didn't have a work from home and tried to introduce work from home had security issues. And we can see, like, all the media is now full, that CIOs, CISOs are on the on very high demand, with new skill sets. So I think everybody's feeling is that others can share bits into it for enrichment of others. Please go ahead.
Ramesh, would you like to share your thoughts?
Hey, so I just put it on the chat. So most of it would be a mandate if you're working for a banking or financial institution. So yeah, there'll be tough time to implement these things as part of your pipelines, but definitely it would be a requirement. So um, and as Devanshu was speaking, after COVID, probably everyone is ensuring that they are not leaving any gaps. So yeah, trying to secure all, I mean, perimeter security, I mean, all the in different level securities are coming into picture everywhere. And these things are becoming mandatory as to be done as part of DevOps and CI/CD pipelines. Yeah, that was my experience, whatever I shared across, and we had to put it into the pipelines and get the reports and see what's happening.
Thanks, Kamesh. Okay, I think Anshu and Venu, please go ahead, and you can move towards the closing. Before closing, I will have 2 minutes to talk about the next year, where we are planning to go.
Sure. I mean, yeah, it was like really interesting talks today. So thank you, obviously, to all the speakers for coming out today and speaking about all the topics that you did. Very insightful talks, and I'm really grateful to all the participants for the questions they asked and just getting the engagement going. Thank you very much. And I learned a lot. This is my first LSP meetup, as I mentioned earlier. Thank you so much. And yeah, I'm hoping to definitely attend the next one. Right, Anshu?
Yep, thanks, Venu, and thanks all who participated today. Right, definitely, we had a whole bunch of new folks today joining in, a whole bunch of people with their first LSP. So we hope to have them in future editions as well. Definitely a whole bunch of interesting talks. For folks who joined us midway or couldn't attend the entire session, yeah, it's there live. It's there on YouTube. So yeah, feel free to follow up. If you have any questions, feel free to put it on the meetup forum, and we'll request presenters to take it from there. Also, all the presenters would be sharing their uh, slides, so that also would be available. So yeah, and hope to have everyone again in person whenever time or everything around us permits. But till then, yeah, we'll continue to meet in the virtual forum. So yeah, I guess that's all from my side. Devanshu, over to you.
Thanks, Venu. Thanks, Anshu, and thanks, LinkedIn, for hosting this. LinkedIn has been supporting us for last 4 years, so expecting that they will continue to support. So if you have noticed, we started our first meetup in June 2012. So this is our ninth year actually, and we will be completing the ninth year with the March event in 2021. So we will be entering in 10th year of this community. So I think with this, request everyone to unmute and have a clap so that everyone can listen to this.
Great job, guys. Good job.
I think the thing we would like to go is till date, till ninth year, we are running it in quarterly mode. With virtual being a success, the moment we get into offices, we'll have the physical ones, but we'll probably continue to do few virtual ones as well. So I am exploring ideas with the organizing team. Organizing means obviously we have Venu, we have Anshu, we have a bunch of other folks who are organizers. So whether we can go bi-monthly in 2021, that would be probably our first target, with more organization trying to support or offering to support us. The crux should be in getting the stocks. So we need more volunteers from you guys, volunteering to talk, to share your experience, and more we have speakers will increase the frequency. And I mean, we've not obviously, we have experienced how to run this in a consistent manner. So we'll not haphazardly increase the frequency of events, but the idea is if you can go from 4 to 6 in a year. So we'll discuss internally and obviously notify all of you guys in the meetup forum. That's my year-end thought to enter into the 10th year of the LSPE. So we'll catch up with all you guys on mail and on the forum, on the blog as well. Thanks all for joining, and have a great weekend and year-end with safety and precautions with all your near and dear ones. Thank you.
Thank you very much.
Thanks all.
Thank you all.
Thanks.
Thank you all.